Okay, we're on still section 5.4. We're going to review a problem or so and then cover the rest of the chapter.
So number 26, 3x squared minus 2x minus 12 equals 0.
All right. In order to do that, in order to complete the square, to find the zeros, what we have to do is divide each term by 3, because in order to complete the square, the leading term has to have a coefficient of 1. So dividing each term by 3, we have x squared minus 2/3 x minus 4 equals 0. All right. Now today's lesson is going to look a little bit different, but for finding the zeros, we're going to add 4 to each side, and we'll get x squared minus 2/3 x equals positive 4, and I left some room so I can complete the square. In order to complete the square, we take half of the b. Half of 2/3 is 1/3. Yeah, half of 2/3 is 1/3. That means that in the parenthesis, I can write x minus 1/3 quantity squared. So we take half of the b term, which is 1/3, and square it, and I get 1/9. And I'm going to add that to both sides. Okay. Well, 4 is 36 over 9, plus 1 over 9 is 37 over 9. And then I can square root both sides to get x minus 1/3 equal plus or minus the square root of 37 over the square root of 9, which is 3, and adding 1/3 to each side. Right, and that was problem 26 from your homework last night. Okay? Any other questions up to 36? I'm going to read the answers in a minute. Pardon? Yes, go ahead. To finish up section 3.4, we're looking at 5.4, sorry. Vertex form of a quadratic function. It has to do with completing the square. The method's going to be just a little bit different. And when you see things like f of x equals x squared plus 8x, let's say plus 3. We want to put this in vertex form. Vertex form of an equation looks like f of x equals a times x minus h quantity squared plus k. The vertex, we can look at an equation if it's in this form. And the vertex is going to be at h, not negative h, but h and k. And those are simply numbers, real numbers. And so is a. This a out here is just a coefficient. And the equation of the axis of symmetry is x equals dh. If you recall what the axis of symmetry is, if we have a parabola, the axis of symmetry is going to be that imaginary line where we have a mirror image over that line of the parabola, and we want the equation of that vertical line. And it's simply x equals whatever the h coordinate, whatever that coordinate is of the vertex. And this is the equation of the axis of symmetry. Okay? So let's take an example. The example I wrote to the left here. I want it to look like the equation on the right. So I'm going to group x squared plus 8x, grouping, put in parentheses. And notice I left a little room there, plus 3. All right. And in the parentheses, I want to complete the square. What number do I have to add to complete the square? 16. Half of the b term and square it. Now what that does, it allows us to write this parenthesis as x plus 4 quantity squared. Okay? I added 16 here. I can't just add 16 to an equation. I've got to balance it off. And I'm going to balance it off by subtracting that 16 at the end. Does that make sense? It's kind of like if I did this. If I told you that x is equal to, let's say, 10. If I went plus 3 minus 3, that still would equal 10, doesn't it? I added 3 and then subtracted. That's the same thing I did here. I added 16 and then I subtracted it. Now this equation looks like x plus 4 quantity squared, and then 3 minus 16 is negative 13. The vertex is not 4, it is negative 4, the opposite of what's inside the parenthesis. Negative 4 and negative 13. And you could plug this equation into your calculator, and you'll see that the vertex is going to be at negative 4 and negative 13 by putting that in the vertex form. That's the first time I've used that.
Magic.
Well, it is kind of. To me it is. This whole smartboard is like magic. Okay, let's take another example. Let's do another one. So we're going to take f of x equals, let's go x squared minus 7x plus 2. It doesn't factor. I want to put this in vertex form. Okay. I'm going to group the first two, x squared minus 7x, and I'll put the 2 on the outside. What number do I have to add to complete the square? Come on. Not 7 over 2. I have to square that, or 49 over 4. My rule for completing the square says I take half of the b term, which is 7 over 2, and square it. That's what I add. Now, this can be written as x minus the 7/2 quantity squared. Now, I added 49/4, didn't I? So I have to subtract 49/4 from the other side. And 2 minus 49/4. Well, I can write 2 as 8 over 4 minus 49 over 4 gives me, take that equal sign, gives me negative 41 over 4. You can put that in your calculator if you want to, and then change to a fraction, whatever's easier. 2 minus 49 over 4. And the vertex is at 7/2 and negative 41 over 4. the equation of the axis of symmetry, x equals 7/2, whatever the x-coordinate is of the vertex. Okay? Given an equation, f of x equals 3x squared minus 12x minus 5. All right, this is a little bit different because our coefficient of the x squared term is not 1. So what I have to do, I'm going to group the first two terms, just like I did before. But I can't complete the square in the parenthesis because remember the leading coefficient has to be a 1. So what I'm going to do is I'm going to factor out the 3. And now I'll complete the square. What number do I have to add? 4. Half of the b term, which is 2, and square it, is 4. Now I can write this as 3 times x minus 2 quantity squared. And what have I added now? What have I added? I haven't really added 4. I've really added 12. If I distribute this 3, I'm adding 12, aren't I? 3 times 4 is 12. I've added 12, so I'm going to subtract 12. Adding 12 to one side of the equation and then subtracting 12. And that makes this negative 17. My vertex is at 2 and negative 17. And the equation of the axis of symmetry, x equals 2. Does that make sense, Michael? Okay. Want to do one more? Remember, f of x equals a times x minus h quantity squared plus k. The a in that last example was 3. So I'm going to do f of x equals negative 2x minus 10x, 2x, negative 2x squared minus 10x plus 7. Put this in vertex form. Group the first two. Leave some room. I cannot use completing the square unless my leading coefficient is a 1. So what do I have to factor out? Negative 2. And I'll be left with x squared plus 5x. What number do I have to add to complete the square? 25 over 4 is right. That means I can write this now as x plus 5/2 quantity squared. That's why I complete the square. Now what did I do over here? I didn't add 25 over 4. What do you think? Negative, what I did was negative 2 times 25 over 4 is negative 50 over 4. So I've really added a negative 50 over 4. which is negative 25 over 2. So I'm going to add 25 over 2. Negative 2 times 25 over 4 is negative 50 over 4, which is negative 25 over 2. So I had to add it at the end. And 7 plus 25 over 2 would give me a positive 14 over 2 plus 25 over 2 gives me 39 over 2. My vertex is at negative 5 halves and 39 over 2. And the equation of the axis of symmetry, x equals negative 5 halves. That's the equation of the axis of symmetry. Yes?
So when you're like adding it from the side of the parentheses to the other side of the equation, does it have to be a positive then?
We're not adding to the other side of the equation. We're doing on the same side of the equation.
Yeah, but
Negative and then a positive.
Why is it a positive?
Because I subtracted negative, because I added a negative 50 over 4, so I have to add 50 over 4. It's like the example I gave you here. If x equals 10, I can add 3 and then subtract 3. And I still get x equals 10. Okay? All right, and I've got one more example that'll be on your test. All right, I want to give you one more example, and this is going to be a test question. I want you to write an equation in vertex form given the following information. The vertex is at, well, let's make it easy. We'll say 2, 5. And this quadratic function passes through the point negative 3, 7. Okay? So it's a parabola where the vertex is at 2, 5, and it passes through the point negative 3, 7. F of x equals a times x minus h, quantity squared, plus k. And let's write down what we know. This is not as hard as what it seems. That means that f of x equals a times x minus what? 2 quantity squared plus 5. If that's the vertex, if the vertex is at 2, 5, then x minus 2 quantity squared plus 5 would be the equation. The only thing that's missing now is the a. We want to find, is there a coefficient out there? And it passes through the point negative 3, 7. So all we have to do is plug in 7 for y, and we're going to plug in negative 3 for x, and solve for a. So we have negative 3 minus 2 is negative 5. Negative 5 squared is 25. So we have 25a plus the 5. And we subtract 5 from each side. And so a would equal 2 over 25. I'm going to take this information and put it up there. And so the equation now would be y equals 2 over 25 times x minus 2 quantity squared plus 5. Okay? So y equals, or f of x equals. And this is going to be a test question on your test on Wednesday. Okay. homework for tonight will be on pages 304, 305, 38 through 52. And you can get started.